this is what happens. Range error, maximum call stack size exceeded. Not exactly sure why that error happens exactly, but the point is it'll stretch really weird. Maybe I'll have a visual up here. Yeah, it stretches really weird, right? That's what happens if you do a set size. You could do an aspect ratio. Let's review that a little bit actually. So over here, yeah, so we have that 800 by 600 image, and like there's a ratio of that. The original ratio is of course 4:3, because if you think of the width and height as a ratio, 800 divided by 600, that's the same as 4 divided by 3, because the aspect ratio is the ratio of the width to height simplified as a fraction. So, but of course I had that 1920 by 1080, and the reason it was stretching is because it's not 4:3, it's 16:9, and we tried to draw it assuming that it was a 4:3, so that's where the problem came into play, because you got 1920 by 1080, it's the same as 16 divided by 9. There's no way to hard code one ratio, because it could be anything that anybody throws at it. You might even have like a 16:10, or not sure what some of the ratios are with some cameras, but they could be really anything, right? We don't want to have to hard code stuff, and that's not ideal. So one way we can deal with that is, like, while maintaining that 125,000 limit, is calculating the best width and height that's still under 125,000 pixels, which, of course, the formula for the width is equal to the square root of, because you know the total number of pixels, right? That's just the width times height. So the total pixels divided by the aspect width times the aspect height. You put this in parentheses and you multiply it by the aspect width. Then the height is equal to this multiplied by the aspect height. Then you can get a width to height that's a certain number of pixels, and the aspect ratio of that width and height is going to be the same aspect ratio. So of course, if we have, I kind of showed you this last time, but if you have an 800 by 600, that's 480,000 pixels. But if you want a resolution, and that's a 4:3 ratio. But if you want a resolution that's a 4:3 ratio, and the total pixel count is 125,000, then you could run it through that formula. So the total pixels in this case should be 125,000. So the width is equal to the square root of 125,000 divided by 4. The aspect width is 4. The aspect height is 3. And then you multiply that by 4, which is the aspect width. So this was 125,000 divided by 12, which I remember from last time that happened to be 10,416. So the square root of 10,400, I rounded this number down. It has some decimal after it. But if you take this, if you round it down, it's about 102. So for the aspect width, the width is equal to 102 times 4. Then the height is equal to 102 times 3, which is 408 by 306. And that's pretty close to 125,000 pixels, but this is 408 by 306 is a 4:3 ratio, just like the original image. And then when I showed you the 1920 by 1080, that was of course 1920 by 1080, like what the image for 1920 by 1080 should be is so you got the square root of 125,000 divided by, that's a 16:9 ratio, so 16 times 9. The width is equal to that times 4. Then the height is equal to that times 3. So I'm going to grab my calculator real quickly. And I got it out this time. So if I were to take the square root of 125,000 divided by 144, then I get basically 29 effectively. Wait, what? Yeah, I guess so. Then I get 29. Oh, and it's not times 4 and times 3, my bad. It's times 16 and times 9. So, this is 24, I believe. Yep. Oh, no, 29 was right. So the width equals 29 times 16, and the height equals 29 times 9. So 29 times 16 is equal to 464. 29 times 9 is 261. So 464 by 261 would be the resolution that's under 125,000 pixels. That's a 16:9 ratio, I believe. So I'm going to confirm that. So 464 over 261, that's a 16:9 ratio, alright. So yeah, 464 over 261 equals 16:9. So that's the resolution we should have for that. So in order for it to automatically figure out the width and height while maintaining an aspect ratio so that it doesn't do any of that weird stretching and shrinking, that's essentially what it does, right? So I hope that makes sense at least. So you just run it through that formula, and that's to calculate the width and height, since we have a limited amount of pixels we can have. And if we want to maintain an aspect ratio, that's what you do. It's not giving us the aspect ratio, it's only giving us the width and height. But there is a way to calculate the aspect ratio based on the width and height. So let's talk about that now. So if you remember from before, the aspect ratio is essentially the width. So yeah, you got 1920 by 1080. The aspect ratio is the width divided by height, essentially. And then a ratio, this is actually a ratio, or 1920, this could technically be, that's the ratio, but the aspect ratio is essentially this in simplest form. So, see, because 1920 divided by 1080 is the same as 16 divided by 9. So the aspect ratio is considered 16:9 because of that. If it was 16 divided by 10, the aspect ratio is 16 to 10 in that case. Does that make sense? So how do we actually calculate these numbers then? Like, how do we actually get this 16 and 9 in the first place? Well, on my calculator, I have a TI-85, which is my favorite calculator of all time. So one thing I can do is, it's going to be hard to see the screen, I think. It's going to be kind of hard. Oh, shoot. The flashlight may not really help too much. I don't know if it will or not. Oh, it'll help if I show it like that. so you can see the calculator screen, right? So we got 1920 by 1080. How do we get this 16 at 9? Well, on my calculator, if I enter 1920 divided by 1080, see that? That's 1920 divided by 1080. What that'll give me is 1.7 repeating, essentially. And what you can actually do, the calculator allows you to convert some sort of decimal into a fraction. So like I can have 1.5. To convert that into a fraction, I hit second math, and then I hit this num button right here, and then I hit more. Oh shoot, I actually hit second miscellaneous, then more, and then I'll get this fraction option right here. If I hit that, it converts 1.5 into a fraction. It's 3/2. But see that 1.778 that you saw, if you convert it to a fraction, it's always going to convert it to the fraction in simplest form. So 16 and 9 is essentially 1920 by 1080 in simplest form. So yeah, so if I enter 1920 by 1080, I can either have it as a fraction, or I can convert it to a decimal. Oh shoot, I'm still showing stuff on the calculator. I'll keep this here then. So 1920 divided by 1080, if I were to convert that to a fraction, it converts it to the simplest form of the fraction. It simplifies it to 16 divided by 9. That's our width and height. That's the width and height we're looking for. So it's possible to calculate the aspect ratio based on the width and height, and that's essentially what we're going to try writing a function for. So how do you even calculate that in the first place? And I'm going to show you how you would do it in mathematics. There's actually two different ways you can do it. You can either find something known as the greatest common divisor, or some people call it the greatest common factor, or else the least common multiple. Those are two different ways you can get it. But I'm just going to do, you saw the GCD on there before potentially. That's the greatest common divisor. So I'm going to show you how to, the greatest common divisor will ultimately lead us into figuring out the aspect ratio. First, we can calculate the greatest common divisor. So I'm going to show you how you calculate that. So the greatest common divisor is a number that you can divide two or more numbers by, and the result will still be a whole number. I don't know if that made sense, but so let's say you have the numbers 16 and 24. The greatest common divisor is, in that case, it would be 8, because 16 divided by 8 and 24 divided by 8. So that would be 2 and 3 respectively, right? Well, so 8 is the highest number that can be divisible by both of these 16 and 24. That'll still be a whole number. You can't divide it by like 10 or 12 or anything higher than that while having it a whole number. I mean, you can divide 24 by 12, but not 16. And it's a number that can divide all the numbers. So 8 is the highest you can divide all the numbers specified here, and it could be 2 or more numbers. Like 32, for example. So you have 32 right here. It's still 8. If you had like some other number that doesn't go into other numbers, that can change what it is. But yeah, the greatest common divisor is 16, 24, and 32 is 8. Because, yeah, I hope that makes sense by now. That greatest common divisor will help us figure out the aspect ratio and effectively do what simplifying the fraction was doing. So based on what the greatest common divisor is, I'll rewrite it here. You Can you guess what numbers we need to figure out the greatest common divisor for? Our width and height. So we need to figure out the greatest common divisor for 800 and 600. And the way we could do that is by factorization, which I don't know if that makes sense, but it'll help us get to it. So let's say, let's see here. Yeah, you basically factor it, and what you're doing is that you know that if you, let's just say you have the number 10. There's several ways you can multiply numbers to get 10. You can say 1 times 10, 2 times 5, 5 times 2, and 10 times 1. Those are different ways you can multiply numbers to get 10, right? Well, when you do factorization, you're figuring out a way to multiply prime numbers to get to these numbers. And a prime number is a number that's not divisible by anything other than 1 in itself. So, like 10, for example, is not prime because you can divide it by 1 or itself. That's true, right? Divided by 1 or itself, which is 10. But you can also divide it by 2. You can also divide it by 5. If these were the only possibilities that you could do, then technically 10 would be prime in that case. 13 is a prime number because you can't divide it by, I mean, you can divide them, but you can't get a whole number, right? So, like, otherwise, yeah, if you did like 13 divided by 2, that's some decimal number, like 6.5, I believe. Yeah, 13 is prime because of that. You can only divide it by 1, and you can only divide it by itself. Sorry, that's a 3. So, yeah, that's what a prime number is. You're figuring out the lowest prime numbers you can multiply to get to each of these numbers. So, maybe I should do maybe I should start with a lower number. So, let's do 32. So you basically have a factor tree and you keep going down until you get nothing but prime numbers. So 32 is the same as like 16. I'm going to do the most redundant way. 16 times 2. 2 is a prime number, so circle it. And 16, you can say 8 times 2. There's another prime number. 4 times 2. There's another prime number, then 2 times 2. Those are prime numbers. So the prime numbers that you circled, you multiply them all together. So 32 is the same as 2 times 2 times 2 times 2 times 2. That's what factorization ultimately lets you figure out. Now, while I did it the easy way mentally, there's of course other ways you can do this, by the way. So you could also go like 8 times 4. That's 32. So you can break that down to 2 times 2. There's 2 2's right there. Then you got 4 times 2. You got another 2 right there, and 2 times 2. See how much faster that was? So the numbers that are like closest to the middle, if you start with that, then you can do it in the least amount of steps possible. Anyway, yeah, so 2 times 2 times 2 times 2 times 2, right? That's what prime factorization does. And in order to get the greatest common divisor, you do it for both of these numbers. So if I were to do it with 800 and 600, I would do, I could do like 100 times 4, but then there's going to be a lot of steps. Actually, let's do it. Or 100 times 8. And that's 4 times 2. 2 times 2. Circle all the 2's. And then 10 times 10. 5 times 2. Right? For each of the numbers. 5 times 2. And 5 is also prime. So the answer for this 800 is 5 times 5 times 2 times 2 times 2 times 2 times 2. Does that multiply to be 800? I know that 5 2s is 32. It's 30. No. 5 times 5 times. I might have done something wrong. Yeah, that's right. This is equal to 800, and those are the lowest primes that you can multiply to 800. And then to get the greatest common divisor, well, do the same thing with 600. So like 100 times 6. That's 3 times 2. Those are primes. 10 times 10. 5 times 2. 5 times 2. So for this one, it's 5 times 5 times 3 times 2 times 2. Yeah. 2, and there's 3 2s. Times 2. Though I'm basically writing all these numbers I circled in order. And let's double check it. 5 times 5 times 3 times 2 times 2 times 2. That's 600. So this equals 800. This equals 600. So that's how you factor out numbers. So to find the greatest common divisor, you're probably wondering how this all ties in. You figure out what each of these numbers have in common. So there's 5, 5, and then there's no 3's up here, so you don't circle that. And then there's only 2 2's right here, so you circle a 2 there, 2 there, and a 2 there. So we circle what they both have in common. So that's 5 times 5 times 2 times 2 times 2. That's what they both have in common. And if you multiply this, you've got your greatest common divisor. This would equal, I believe it's 200. So 5 times 5 times 2 times 2 times 2 is 200. So the greatest common divisor for 800 and 600 is 200. Because, yeah, that's the highest number you can divide. But here's the key. I'm going to erase this, and so we got 800 and 600, and the greatest common divisor is 200, right? Well, if you take 800 divided by 200, what do you get? 4. 600 divided by 200, 3. Did we just calculate our aspect ratio? 4, if it's 800 to 600, it's the same as 4 to 3. So that's how we can calculate our aspect ratio right there. But how do we program that exactly? That's the whole other thing. So that's how we can calculate. We have a way to calculate our aspect ratio now. The least common multiple is sort of like this, except the opposite in a sense. But so how do we get it to do it in programming? Well, I'm gonna actually create 2 different variables for each number. Number 1 equals 800. Number 2 equals 600. Those are the 2 numbers, right? Those are the 2 numbers we're figuring out our greatest common divisor for. So we'll create some sort of function to, and actually I don't think I'm going to really create a function for the greatest common divisor itself. I think I'm going to create this where we get the aspect ratio. So we're going to create 2 different functions to get the aspect width and the aspect height. So like get aspect width, sorry about that, and I think you specify the 2 numbers that you want to do, and then same thing with the height, right? Same thing with the height, you specify the width and height. because you need both of them to calculate any of them, but if you want to get the width all by itself, then you can do that. You want to get the height all by itself, you could do that. I don't know, would it make sense to do it in separate functions? I don't know. Anyway, to get it to do it in programming, what we can actually do is we can take our let me think here. We can take our number 1 and we can like repeat a certain operation. So we can take number 1 and mod it with number 2. Like we can keep doing this and kind of cycle through in a way. So modulus, this is considered the modulo operator. They call it modulus, but it's the modulo operator. It's a percent symbol, and what it does is it returns the remainder of a division problem. Sorry, my camera just shut off for a split second. What modulus does is it returns the remainder of a division problem. So you could do like n1 divided by n2. But let's just, for simplicity's sake, let's just do like 13 and 5. So you could do like 13 divided by 5. And if you have a number with a decimal place after it, that's the same as 2.6. So, like, right, you do that division problem, then if you floor it, it's just 2. But never mind that last part. So you divide 13 by 5, you get 2.6. The 0.6 is essentially part of the remainder. Anyway, if I were to do it with the modulo operator, let's do it in the form of long division. So 13 divided by 5. So 5 goes into 13 2 times. So that's 5 times 2 is 10. You had 3 left over, right? So you could say 2.6, but you could also say 2 and 3/5, right? 2 and 3/5. That's the remainder, right? But another way you can write this is 2 remainder 3, because if you don't do it as a fraction like this, it's a remainder of 3. So yeah, 13 divided by 5, the remainder is 3. So if you were to say like 13 mod 5, that's 3. Because the remainder of that division problem is, sorry, that's a circle, 3. So yeah, we can do an operation that involves the mod operator, the modulo operator, with 800 and 600. But what we can do is we can set our second number equal to the remainder of number 1 and number 2, or number 1 mod number 2. Set that to this. But then we can eventually number 1 is going to become what number 2 used to be. So we're going to have some sort of temporary variable to store what n1 currently, or what n2 currently is before it changes. Then it changes after the operation's done. Then we want n1 to become what n2 used to be. And we can repeat this until a certain condition is true. So let's just run through this a bunch of times. So if I have 800 divided by 600, I'm going to, I wish I would have written this in the top, whatever. So maybe I shouldn't have erased that either. So n1 equals 800, n2, n2 equals 600. So let's run through this right now. So the temporary variable becomes 600. Okay, then that'll be relevant for later. So n2 becomes, what does n2 become? n1, 800 modulus 600. That's going to be 200. Okay, because 800 divided by 600 is 1 and 200 over 600, which is the remainder of 800 divided by 600 is 200. Then N1 becomes what N2 was, which was 600. Okay? So now let's run through it again. So based on these numbers, so you got 600 modulus 200, and 600 divided by 200, the remainder of that is actually 0. The remainder of this is 0. So now N2 becomes 0. Okay? Because the remainder is 600, yeah. And then N1 becomes what N2 used to be, which is 200. So, notice anything yet? Well, that's our greatest common divisor, if you remember, of 800 and 600. That's 200. So, our N1 becomes our greatest common divisor when N2 is 0. So we can actually keep running this until N2 becomes 0. So we could create a while loop. So like while N2 does not equal 0, that's how you write it in programming, of course, then run through this. And then when it's done, N1 will be whatever our greatest common divisor is, and then we can return N1 with the greatest common divisor. Otherwise, down here we could do our operation where we get the actual aspect ratio. We could take, because N1 is, we return the width, if we want to get the aspect width. We return the aspect width divided by N1, and we'll get our aspect width. And then we do the same thing, but we return the aspect height. This is just the width, I believe. The width divided by what we calculated with the greatest common divisor. And that's the aspect width. The width divided by greatest common divisor. And then we do this again for the height, and instead we return the height divided by the greatest common divisor. And then that'll be 4 and 3 when we run those functions. So this isn't too good to be true, is it? I mean, is this actually like real? I mean, yeah, this can't possibly be true, can it? Well, let's try it on that 1920 by 1080 just to make sure. So 1920 by 1080. So and we know that this is going to be true if we run through this and get 16 and 9. I'm not going to do the factor tree, that would take too long, but as long as we get 16 and 9, then we know it worked correctly. So shoot, I accidentally let's write it up here. So temp, if you remember what it said, temp equals N2, and then N2 equals N1 modulus N2, and then N1 becomes temp. So this will keep running like while N2 does not equal 0. Oh, and by the way, I forgot something. Let's run through it the other way around and make sure we get the same thing. So we did 800 and 600. What if it was 600 and 800? Will it still work, or is it too good to be true, sort of? Well, let's run through it up here. So temp is 800. Don't really worry about that yet. So we're going to do 600 modulus 800. That's, since it's less than 1, not even 1. So 600 modulus 800 is actually 600. So N2 becomes 600. N1 becomes 600, I believe, because or 800, N1 becomes 800. Sorry. Oh no, something is definitely not right. So you got 600 modulus 800. The remainder is 600. So N2 becomes 600. So temp is what N2 is. Oh, they basically, actually, yeah, that is right, because they switch around. Sorry, that's an 800. Sorry, I'll rewrite that. Sorry about that. That's an 800. So basically what happened is N1 and N2 switched around this time. Let's run through it again. So now we're going to be doing what we did before. So yeah, 800 mod 600, that's N2 now becomes 200. And then N1 becomes, or N2 used to be 600, so now N1 becomes 600. So now let's run through it again. So 600 mod 800. Hold on. Something's not right, obviously. I'm not doing something right. 800 mod 600 is 200. Yeah, and 2 is 200 actually. Then N1 becomes 600. So now we run it with this. So yes, so now we run 600 mod 200, that's 0. N2 equals 0. And then N1 becomes, the N1 is what N2 was, 200. When N2 is 0 and 1 is 200, we still got 200 despite the order that we did it in. Now it's not going to work with more than 2 numbers. I don't know how that's going to work, but this will work perfectly fine. Alright? That can be an exercise for you if you really want to do more dimensions than that. Okay, let's real quickly run 1920 by 1080 just to make sure it works. So we do 1920 mod 1080. Let me think, what was that? That's like 640 or 630 or something. What's 1920 minus 1080? 1920 minus 1080, 840. So 1920 mod 1080, that's going to be 840. So N2 becomes 840, and 1 becomes 1080, and 1 equals 1080. So then you run it again, N2. So now it's 1080 mod 840. So I would subtract. I think that's 240 actually. 240. And 1 becomes 840. So then you run N2 again. That's 840 mod 240. I don't know what that I don't know. 840 divided by 240, that's got a remainder. Okay, so I think you subtract 840 minus 240, 600. That sounds about right. So now N2 becomes 600, and 1 becomes 240. Something doesn't seem right. I feel like I could have done something wrong. So, yeah, N2, that does become 600, it looks like. You do 840 mod 240. No, that's not right. 840 mod 240 is 120, actually. This is 120, I'm sorry. And this is 240. So then N2 becomes 240 mod 120 is 0 because it's 2 times. So so this is 0, so that means N1 is what our greatest common divisor should be, which is 120. Looks like it's 120. So did you take, let's try it out. So 1920 divided by 120, and then divide them out. We should get 16 and 9 if we did our thing correctly. Oops, not 19, 9. So if we did it correctly, that's what we should get. So, oh yes, 120 times 6. Remember when we did our square root math? We actually got 120. Then we times it by 16, it is 1920. Oops, 1920 divided by 120, that's 16. Then divided by 9, 1080 divided by 120, that is in fact 9. So we need to write a function that does this, and we will get the aspect width and height. That's pretty ridiculous what's involved with that, but there's a way to calculate the width and height since we don't have any native functions that allow us to actually do that. So let's finally go back to the computer for once. So then the aspect width is equal to, right, so we need some temporary variable to store our first number, or our second number. So now we're going to do, I think it might make sense to write a separate function for the greatest common divisor. Function GCD, that would be N1 and N2. So temp equals N2, N2 equals N1 mod N2, and then N1 equals temp. And this happens while N2 does not equal to 0. Right? So while N2 does not equal to 0, so by the time this is done, N1 is going to be our greatest common divisor. So all we have to do is return N1. So if we want the aspect width, then we're just going to do the divisor equals GCD with W and H, right? And then we're going to return the divisor, or no, the width divided by divisor. And if we even did that right, then get aspect height. Then we're returning the height divided by divisor. And yeah, we need both arguments because of that. Did the image resize where it should have? Well, what is res width when we run it? Ooh, W is not defined, that's why. Wait, what line? 109? So we have to actually return image.width divided by divisor, and then same with the height. Image.height. So res width, get width is not defined. Line 97, get width, we're supposed to say get aspect width. Right. And then get height, we're supposed to get aspect height. Res width. Oh, looks like we got something now.